Next, for sequences and series. Insert 3 geometric means between 162 and 2. When we say inserting geometric means, we are to add terms between 162 and 2, so as to including 162 and 2, we'll come up with a new geometric sequence. We can do this by focusing on our general formula for all terms in a geometric sequence. You have a sub n is equal to a sub 1 times r to the power of n minus 1. Here, we are going to consider 162 as our first term. This would mean 2 is not our second term, though it's the second integer, but it would be our fifth term. Why fifth term? It's because we are inserting 3 different terms between 162 and 2 to become a new geometric sequence, and those are the geometric means. In short, we're looking for a sub 2, a sub 3, and a sub 4, which are c sub 1, c sub 2, and c sub 3 respectively as notations for geometric means. Here in our formula, we can solve for a sub 2, which is the second term. However, we don't have the value of our r. What we know is our first term. We can try applying the formula for the fifth term we now call as 2, because this is equal to a sub 1 times r to the power of 5 minus 1. So a sub 5 is 2, equal to our a sub 1 is 162 times r raised to the power of 4. Then we can divide both sides by 162, and by symmetric property, r to the power of 4 is equal to 2 over 162, or simply equal to 1 over 81. That's the simplified form of 2 over 162. Then let's take the fourth root of both sides. When we take the fourth root of both sides, what will happen here is that for your left hand side, it will return to r the ratio that we're looking for, and we will take the fourth root or a radical expression of any fraction. We are going to distribute that to the numerator and denominator. So fourth root of 1 is 1, and the fourth root of 81 is 3. In short, our common ratio is 1/3. This will now be used to solve for the next few terms. We don't need to use the original formula in solving for a sub 2, because a sub 2, or equal to your first geometric mean c sub 1, is just the result of multiplying your a sub 1, 162, by your common ratio. When we multiply 162 by 3, that would be our second term, or again, the first geometric mean that we are adding. So when we divide this, we will get a result of 54. Okay? 162 divided by 3 is 54. That's our second term, or the first geometric mean. The next geometric mean is our a sub 3, or again, this is our second geometric mean, is the result when we multiply the previously identified geometric mean 54, or our second term, to be multiplied by the same common ratio. So a sub 3 is equal to 54 divided by 3. You will get a result of equal to 18. And this is your second geometric mean. Now for the last geometric mean, or our fourth term of the new geometric sequence, is our, again, c sub 3. This is a result when multiplying 18 by the same common ratio. So you will get 18 divided by 3, you will have 6, and this is your a sub 4, or the third geometric mean. You will know whether your answer is correct or not by looking at the idea that if ever you're going to multiply this fourth term by the same common ratio, will it return to the a sub 5, which is 2? Of course, 6 divided by 3 is 2, and the answer is yes. So our three geometric means to be added between 162 and 2 are 54, 18, and 6 respectively, coming up with a new geometric sequence 162, 54, 18, 6, and 2 with a common ratio of 1/3. Next, for sequences and series. Subscribe now!